So welcome back guys, this is Madhav PVL and today we are going to discuss about a few major topics in computer organization and architecture. That is, so let me just start now. So basically today we are going to discuss about a few topics which were belonging to our college course outcome 3 from the subject computer organization and architecture. So basically we need to know what is meant by an input output devices. So as we had learned in our lower sections, that is in our lower classes, like input, process, output. So for obtaining a process we need an input. So output is nothing but the processing the input, and the result is known as an output. So the input output devices, so we are going to discuss it today at first. So keyboard is used to control. So controlling units can also be called as an input units for now, because we don't know in depth about that, right? So basically now we can call it as an input. So now let me just get into this topic. So basically, if we just see, this is input. If we just think like this is input, and then to the processor, in our lower classes we may just write like this: input, process, output. So now we need to know what is in this between. So we need to know what is there in this both things, between this both things. So that is nothing but input, process. So input is nothing but giving data to a processor to just complete a task. So the giving data cannot be directly given to the processor. It need to just follow some steps or some rules. So let me just show you one thing. So now if we just see, we need the help of buses. So we need help of buses to just transfer our data from input with a process. So we, in this input output devices concept, we also will learn about storage devices, the primary storage devices and secondary storage devices, and this also introduce about buses, and then IO devices to CPU and memory and interrupts. So this is a brief introduction about input and output. So input and output is nothing but just giving a values to a processor and then waiting for the result. For these things we use this input and output modules. So the two important modules of a computer system are the processor and the memory module. So we need input output for this both things, as the processor is nothing but it is a part of CPU. So the CPU, according to the machine language, we call CPU as a processor, because processor is quite different from CPU. Processor is nothing but it performs all the arithmetic and logical operations to just complete a task properly, and the memory module is nothing but the data which is required for the input, and also the data which we get as a result for output. Those all will be stored in this memory module. And the third key component is the IO module. IO module is nothing but this input output blocks. So the input is drawn as a block, right? So for understanding reason I was just telling, so we draw input as a block and then output as a block and then buses as a block. So these blocks are nothing but these IO modules. So IO modules are these blocks, and the processor is nothing but it performs ALU and then all arithmetic and logical operations. And then the memory, as I had said before, we will just store all the data which is required for both input and then output in this memory module, and also the final result also will be saved here. So this is also one of this, right, which belongs to this introduction. So there are several reasons why an IO device or peripheral device is not directly connected to a system bus. So system bus is nothing but the place where the processor will get the data. So here we are just telling like this bus. So actually if we just see, this bus will be directly connected to the processor. So directly connected to the processor in sense, so the processors directly will be can't be given a memory, right? So that is our question. Why can't we just give a memory to an IO device directly with the help of a system bus? So there are wide variety of peripherals which various methods with various methods of operation, that is keyboard and then printer, and also we have mouse. So these are the peripheral devices which are used as an input modules. So the data transfer rate of peripherals is often less slower than that of the memory or processor. So basically, if we need to just send the data directly to an system bus, then it may not be that much efficient, because if we just consider an example, a man who was just bringing down the blocks with the help of a step. So if a man alone walks from the up stage to the down stage, then it may take a lot of time to just reach all the things to the down stage, right? As if we just consider this as a blocks, as a floors. So while coming down, it will take so much of time. This can be managed with the help of with a group of people. So if we just consider 4 people on the same stairs who was just passing down those rocks with the help of this 4 people, and this 4th person will just place it here, then imagine it would be easier. So this case is much easier when compared to this case. So this case is much efficient. So efficient is nothing but time complexity will be very less. So our main aim of a computer organization is to just complete our work as much as speed as possible. So it is slower to just directly connect into processor, and then peripherals uses different data formats and word lengths than the computer to which they are attached. So the major function of an IO module are control and timing and processor communication and device communication and data buffering and error redirection. So these are the major functions of an IO module. As we had discussed, IO module is nothing but the input output modules. So it will just these are just used for control and timing and processor communication and device communication, data buffering and error detection. So basically control and timing. So the IO function includes a control and timing requirement to coordinate the flow of traffic between the internal resources and external devices. So basically, if we just work on a simple thing in a certain intervals of time, that is by taking rest for 5 minutes and studying for 10 minutes, 5 minutes, 10 minutes, 5 minutes, 10 minutes. So if you just perform this task, then it will be very easier to complete task in an efficient way. So the control and timings will be a major part for the input output modules. So it includes a control and timing requirement to coordinate the flow of the traffic between internal resources. So if we just say, if we just perform A plus B from one window, and then if we just perform A minus B from one window, we need to just get the result, which one we can just get these both results at a time according to us. But internally there will be many processes, that is there are many processes in ALU unit to just perform this both operations. So the control and timing will just give the specialization for this both, that is first if we perform A plus B, then second it will just perform A minus B at a certain intervals of time. It will just break this both things, and it will just manage to give the result as much fast as possible. So the processor interacts with the IO module to check the status of the attached device. So the IO module returns the device status. If the device is an operational ready to transmit, the processor requests the transfer of the data by means of a command to the IO module. The IO module obtains a unit of data from external device. The data transferred from the IO module to the processor. So if we just see this, if we just insert a device to a processor with help of external, that is with the help of a CPU, we will have the insertion units, right? So if we just insert the things like that, so it will just check for the so what we can say, so if we just insert a mouse to its USB cable, and then after it gets inserted, then it will just show a pop-up right here, I think so. So it will just show a pop-up here, right? Your device is ready to use. So what does it mean? So the softwares or the hardware functions which were inside this mouse will be just installed into our device for a better usage. So it will just show a pop-up like this device is ready for use. So then the processor will just interact with the IO module. Here IO module is mouse. Here IO module is mouse, and then processor is CPU. So the mouse reacts with CPU, and CPU will just transmit the data, and then required softwares and basic conditions will be installed, and then it will just transfer the data from the external device, that is from mouse. So the data gets transferred with the help of this mouse to the processor, and then our task will become easy. And then processor and device communication. So during this IO operation, the IO module must communicate with the processor with an external device, with the help of an external device. That is nothing but if you just consider this. So now processor communicating involves the following: command decoding, data status reporting, and address recognition. So as we had said before, the transmission of data is nothing but if we just place an USB to our laptop and we just try to copy the films from the laptop, then externally we may feel like it is just doing only one thing, like it is just copying the data from one device to another device. So it may not be a big task, but according to the computer organization, these are the processes which were just happening behind to just copy a movie into a USB drive. So that is a basic example which I want to just say. So during this IO operation must communicate with the processor with an external device. So if we just insert a pen drive, then command decoding. So the movie is nothing but it's just a bit of code. It's just a bit of a binary code. So that binary code will just run in our media player, and then the picture and the audio will combinedly just visible to us in any devices which we connect. It depends upon ourselves. So the data transfer is nothing but the movement of the binary code according to the computer organization, but according to us, transfer of a movie into a USB drive. And then status reporting. So status reporting is nothing but how much of data is just inserting into USB drive. So status reporting is just that. And then address recognition is nothing but how much it is storing and where it is storing. So these all things will be done with the help of a processor and device communication. So command decoding accepts the command from the processor, typically sends signals on a control bus. So as we know in our before classes we had just discussed about this buses, right? So control bus is nothing but it will just control the IO unit, and then processor unit, arithmetic and logical unit, and it controls the whole computer so far to just do our things very easy. We can just say like control bus is just like a human brain. So control bus is just like a human brain. So command decoding is nothing but it just accepts from the processor and then sends the signals to the control bus. Data. So the data is nothing but the exchange between the processor and the IO module from the data bus, as we had discussed it before. And then status reporting is nothing but, so if we are just sending data and if the data is still transferring, then it will just show a green flag or green flag to its internal system, and it will just show us like sending file taking approximately 5 minutes or like that. So we can just use the signals like busy or ready like that. So this is a very basic thing. And then address recognition is it will just show the status, or it will just recognize the address for every peripheral it controls. So it will just show us how we are just using this device, or how amount of data is getting transferred and how much time it will take. It depends upon that system. So device communication is nothing but this communication involves the information and data transfer. That is nothing but device communication is nothing but the interaction between the processor and the IO module is known as a device communication. And then data buffering is nothing but the mismatch of speed of CPU, memory and other peripheral devices. So the IO module store the data in the data buffer and then regulate the transfer of the data as per the speed of the devices. So if we just see if we just consider our RAM value as 4 GB, and if we want to just perform a process of 2 GB, then the speed may differ. And if the RAM value of a laptop is 10 GB, and if you want to perform a task of 2 GB, then its speed may differ. So the data buffering will depends upon the speed of the CPU memory and the speed of the peripheral devices. So that is data buffering. And error detection is nothing but it is because of the mechanical and electrical malfunctions which were reported by the devices. So error detection is just a thing like, so every function in a laptop or in any input or output devices will just follow an algorithm. So algorithm is followed. So algorithm is nothing but the step-by-step process of completing a task. So error detection is nothing but, in our previous classes we discussed about the basic errors, but now we are discussing about the concept of error detection. So error detection is nothing but, if in this algorithm if any one step fails to execute, then that is known as error detection. So if, for example, we can just see here paper jam. So if you need to just print a paper, if it is not just printing the paper outside, then it is an error. So it will just detect the error like that. And then block diagrams for IO modules, so control and timing. So this IO function includes the control and timing requirements to coordinate the flow of traffic between, as I said before, and then input output modules. So data register, external devices, status control register, and external device and interface logic. So the whole input and output data transfer will be done with the help of this IO logic. So IO logic is nothing but the input output module. So with the help of this input output module in our CPU, the data gets transferred from one device to another device. So in this it consists of system bus along with that. So data register is this. So it will just collect the data from the external devices and it will just send it to our data register, and it will be just sent in the form of a data lines. So with the help of this IO logic, the whole data will just gets transferred from one device to another device. So the example is port A register, so timing and control register, status register, port B register. So to IO device to CPU. So from IO device it is just copying the data to this CPU. So as we have discussed all these things in our before things, so if we just look into this diagram, we can just get a clarity like, so this is nothing but the truth table. So IO controller or status register. So basically CPU tells the device what to do. So CPU is nothing but the central processing unit, so it will just use it for the processor of a computer. So CPU checks whether the task is done or not. So data register, CPU transfers the data to and from devices. So device electronics performs actual operation. So it is just a diagram for that. And then video display devices. So this is most common output devices which we use is our laptop monitor, or if we just consider our desktop monitor, that is a very best example for our video display devices. So before times the video monitor is made up of a cathode ray tube design, so CRT design. So a digital memory, a frame buffer which display the image is stored as a matrix of intensity values, a monitor. So we will just discuss in the upcoming slides. So this is our before monitors which are used to be 3 to 4 years back, and then this is the internal structure of this same. The picture may not look much similar. So basically this is the internal structure of a CRT in a monitor. So these are the units in which how the CRT will be. So it will be in the form of lines, if we can just see here. So it will be in the form of lines, the data will be stored in the form of lines, cathode ray tube. So basically here this is the cathode. So if the electrons will be sent with the help of this vertical lines, and then it will just deflected from these electron lines, and the deflected electron beam will just hit here, then the collision may occur here, and then this collision is nothing but our screen view. So our screen view is nothing but this collision of these electron. So with this amplifier, so the data will just gets separated and then the collision occurs. So this is a basic principle for cathode ray tube. And raster scanner is nothing but if we just consider these images, so basically it will just draw a line, so it will just scan line by line. So if we just consider our TV, so if we just try to see our TV from sideways, or if we just try to see our TV without even blinking our eyes, so we can just come to a conclusion like there will be some lines which were flowing from upside down or from down to up. I'm not sure about that. So basically the lines will just follow a route from up to down or from down to up. So if we can just see our TV will work on this raster scan. So raster scan is nothing but reading the data line by line, and if we just consider this, so we need to just perform a circle here. So raster scan is nothing but it will just write the data onto the screen with the help of these lines, and wherever it is required, then it will just place a dots here, and then after placing the dots, it will just apply it on a screen. So raster scan is nothing but reading the data and displaying the object as a set of discrete points across each scan line. So it will just it is just referred as a pixel. So picture elements, that is nothing but the pixel. So here we can just see it is not much important, but if we just go in depth into this electronic subject, then this may work. So here this part is considered as this, so it should be, so this is a raster scan. So raster scan is nothing but so this is keyboard or mouse. So if we just click the play button, so it will just go into this and it will just consider the memory, and then after considering that memory, so it will just send it to the IO port and then CPU, and then now again it will just bring back the data from the CPU. That is nothing but this dots which are need to be presented on the lines, and then finally it will just send it to a CRT, and CRT will just after completing the raster scan, that is nothing but reading this lines from the CPU to this. After reading this, it will just place the dots, and then after the dots are placed, it will just send it as an electron to this cathode ray tube, and it will just hit back at the end, and the picture will be presented to us. So random scan or vector scan. So the random scan or vector scan is nothing but this is advanced one. So this is nothing but as we are discussed now, computer organization is nothing but working for the best. So we need to just get this efficient thing right. So if we need to just get something efficient, then we need to just work on it. So if we just work on it, this random scan is nothing but, so it will just perform this scanning, and it will just perform those vectors or dots only wherever it is required. So if we just if we need to just perform this smiley onto the screen, so only this is just scanned with the help of the sensors, and then it will only just send it to CRT, and then it will be only present onto the screen. As now we can see only the required area is selected, and then it is just presented onto this TV. So again it is same from CPU, it will just send it to the video controller, and then the data will be transferred onto the TV. So the advantages of the raster scanner is nothing but lower cost, filled regions or shaded images. So disadvantages of a raster displays is continuous primitives must be scan converted. So as I said before, if we just get to see our TV from a closure view, then we can just get this things. So this is one of the most disadvantage for a raster scan. So the advantages of a vector scan is very fine detail of line drawing, as I said before. Only the things which we want to display, only that will be scanned and that will be presented onto the CRT. So this is an advantage of the vector display. And then if the monitor is ready to display another character, the display status register is set to 1. When data is written to DDR, so DSR 15 is set to 0. So the character in a display data register is displayed. So this is nothing but the procedure in which the data is just going to be as an output of monitor. So this may occur. So input output subsystem. So there are three ways that computer buses can be used to communicate with the memory and the IO. Used to separate buses, one for memory and other for IO. So if we just uses two separate buses, one for memory and other for IO. So use one common bus for both memory and IO, but have separate control lines for each. Use one common bus for memory and IO with command control lines. So these are the subsystems in which the buses can be communicated with the memory and the IO. So here we will just get into a deep. So memory mapped IO and isolated IO. So the memory mapped IO is nothing but the whole data. Let me just read this. So there is a single address space for memory locations and IO devices. So if we just consider this, both the memory and then IO will be in a same bus. Both the memory and IO will be in a same bus. And then the status in the address register memory locations are in the same machine instructions which are used to access both the memory and IO devices. So we can just say like both the memory and the IO units are at the single address. So that is memory mapped IO, and then so the memory and the IO address will be in a same position. Therefore the same machine instructions are used to access both memory and IO devices. Isolated is nothing but the memory will be in one bus and then IO devices will be in another bus. So whenever the usage of IO devices is required, so the memory whenever the IO devices needs the use of a memory, it needs to just take the permission from the control unit, and it will be needed to just use this memory whenever it is required in an isolated IO. So IO devices is treated like a memory device and so given memory address, both have same address space, so have separate address spaces. Some instructions can control both IO and memory. Separate instruction control read and write operation in IO and memory. Normal memory addresses are for both. In this, IO address are called as ports. Lesser efficient, more efficient due to separate buses. Smaller in size, larger in size due to more buses. Simpler logic is used as IO, is also treated as a memory only. In this, it is complex because it is separate, which is used to control both. So these are the differences between the memory mapped and isolated map. So the data transfer, synchronous and asynchronous. So all devices derive the timing information from common clock line. Asynchronous, no common clock. So synchronous is nothing but the clockwise direction, and asynchronous is nothing but no not clockwise direction. So stroke control, handshaking. So if we just consider this block diagram here, so the data bus strobe, so the from source the data will be transferred into a destination unit. So and then strobe is nothing but it will also just show our destination unit there, and then the destination initiate for strobe for data transfer, and then timing. So it is a sequence of the events, handshaking principle. So asynchronous, a transmitted character can be detected by a receiver from knowledge of the transmission rules. When a character is not being sent, the line is kept in the one state. The initiation of a character transmission is detected from the start bit, which is always 0. The character bit always follows the start bit. After the last bit of the character is transmitted, a stop bit is detected when the line returns to one state for at least 1 bit time. So the asynchronous is nothing but the clockwise transmission. So this is block diagram for the asynchronous communication interface. So programmed IO and interrupt driven IO and direct memory access. So these are the very basic forms of input and output devices. So programmed IO is nothing but it gives direct control to the IO operation. So including sensing device status, sending or reading or write a command and transferring the data. So programmed IO is nothing but the processor executes the program that gives a direct control to the IO operation. So in this programmed IO we can just gain a direct IO operation. And then while if we come to interrupt driven, so the interrupt driven IO is nothing but, if we just consider in this programmed IO, if we are just going in a process and then if interrupt driven IO raises an interrupt, then the programmed IO, the program which was running at this programmed IO will just stop for a while, and the interrupt which is raised in this interrupt driven IO will just first execute, and then after that the data which is stopped in the programmed IO will just continue. So that is nothing but the interrupt driven IO. And DMA is in direct memory access, the IO module and the main memory exchange data directly without process involvement. So that is DMA. And then IO commands. So there are 4 types of IO commands that an IO module will receive when it is addressed by a processor. So control, which is used to activate a peripheral device and instruct it what to do. These commands are specific to a particular type of peripheral device. So control unit is nothing but it will just give the command to a device, peripheral device, to just perform an operation. So control is nothing but to activate a peripheral device. And then test is just used to check the conditions of the IO modules in our peripherals. That is nothing but, as we had discussed it needs some softwares and hardwares which are need to be installed into a computer before using an out peripheral device. So those things will be tested, and then finally it gives a certificate like this device is ready to use. Read is nothing but it causes the IO module to obtain the data from the peripheral device and place it in an internal buffer, and write is nothing but the writing of the data from the peripheral device into an internal buffer. So basically programmed IO is nothing but the programmed IO, the processor executes the program that gives the direct control, as we had discussed it before. So from CPU to input output, and then input output to CPU error condition. So it just checks the status, and then again finally it will just give the output, and then from output it will go to CPU, and then after going to CPU finally the data will be stored in the memory, and then it will just check the process is done or not. If it is not, then again it will just start from the beginning. If it is done, then it will just check for the next instruction. That is programmed IO, and this is an example block diagram for that. So from IO devices to CPU data register, so the data will be transferred from there, so the final output, and then this is an example for that. So this is an example for just inputting a device, so reading a data register and then checking a flag bit, and then operation completed or not, as I discussed it before. And interrupt driven IO is nothing but if any interrupt occurs, then it will just stop the condition, and then it will just perform this interrupt driven IO, and then it will just come back to its main thing. And then this is nothing but a daisy chain property interrupt. So this is nothing. So if we just consider this 3 devices, and if 3 devices are working only on a single request, so if these 3 devices are working on a single request, so the outputs will be same and the inputs will be same, but the work will be divided into 3 parts. So if interrupt occurs, then it will just satisfy those conditions here, and again the normal process will start there. So this is a daisy chain priority interrupt. And then here you can see the truth table for the priority encoder. So we need to just get this block diagram. So direct memory access is nothing but getting a direct access to the processor. So this is not much efficient because it takes more time. So this is direct memory transfer access. So burst or block transfer of DMA, cycle steal or single byte transfer, or transparent or hidden DMA. So burst or block transfer. So burst or block transfer is nothing but it is the fastest DMA mode. So in this 2 or more data bytes are transferred continuously. So the processor is disconnected from the system bus during DMA transfer. N number of machine cycles are adopted into the machine cycles. So in this DMA it holds the signals, and then if we send a particular block of memory to the processor, then this is known as the block transfer of DMA. In this way we will just transfer all the data bytes between the memory and IO devices. So it is one of the fastest DMA mode. It will just transfer the data in the form of different blocks. So different blocks will be following an order and a timing control, and then just getting inside to a processor or a memory device for performing an activity in DMA. And cycle steal is nothing but this is slower than the burst DMA because it transfers only 1 byte at a time. So it holds the signals and enters into a slave mode. So basically it will only just perform only 1 byte. That is, if you are having a huge data, then cycle steal or single byte transfer DMA is not much more efficient than that of the burst DMA. And then transparent DMA is nothing but the transfer of the data between memory and IO devices. This operation is transparent to the processor. So in this mode, instruction execution speed of the processor is not reduced, but the transparent DMA requires a logic to detect the states when the processor is floating the buses. So transparent DMA transfer is nothing but it will not use many buses, like so the control buses, those all things, those are not used. So it will just transfer the data very transparently. The whole operation is transparent to the processor. And then secondary storage devices, that is communication between the disk and the main memory, is run through DMA. The following information must be exchanged between the processor and the disk controller in order to specify a transfer: main memory address, disk address, and word count. So the main memory address is nothing but the first main memory location of the block of words involved in the transfer. So the disk address is nothing but the location of the sector containing the beginning of the desired block of words. Word count is number of words in the block to be transferred. So the disk format is this. So disk operation is nothing but the transferring of the data from one device to another device. So secondary storage devices are need to be stored permanently or either magnetic or optical devices. Magnetic devices is nothing but the magnetic hard disk, floppy disk, magnetic tape, and optical devices, CD-ROM, CD recordable, CD DVD. So if they are if they want to be stored permanently, then we need to use this optical devices, and otherwise we need to use this magnetic devices to store permanently or like that. So a disk is a circular platter constructed of metal or a plastic coated with a magnetizable material. As we know, CD will be in the form of this. So this will be written here, the lines will be written, the data will be written on the CDs as if we listen before. Our people use it to tell like please don't touch with a bare hands because the data gets erased. So we may also hear a very silly things like with the help of an eraser they will just remove the data with a pen eraser. So that may not work, I think so, but I had heard that thing. So basically the disk will be in a form of this. We can read or write operation, and then secondary storage devices will be like this. So seek time is defined as the amount of time it takes the hard drives to read or write its physical location and the piece of the data on the disk. So seek time is nothing but the time which is required for copying or writing the data in a physical location of a piece of data into this. So TS is equal to M into N plus S, where M is equal to constant that depends upon the disk drive, and N is equal to the number of tracks traversed, and S is equal to the startup time. So this is seek time, and the rational delay is the amount of the time between the information request and how long it takes the hard drive to move to the sector where the requested data is located. So in other words, it is a time measurement in milliseconds, how long before a rotating drive can transfer data. So the rotational delay is nothing but how long the rotating drive can transfer the data, and the transfer time is T is equal to B by Rn, where T is equal to transfer time and B is equal to number of bytes. N is equal to the number of bytes on a track, and R is equal to the rotational speed. So input output process will be like this. After knowing all these things, we need to just consider this as an input output process, and then see what CPU operations are in the form of this. Peripheral component interconnect. So PCI is developed as a low cost bus that is truly processor independent. It supports high speed disk graphics and video devices. PCI has a plug and play compatibility for connecting IO devices. To connect new devices, the user simply connects the device interface board to the bus. So PCI bus in a computer system. So it is one of the bus which is used to transfer the data in between the external devices and then into the main memory. So this small computer system interface. This is narrow bus, wide bus, single-ended transmission, high voltage differential. So USB is nothing but, as we know, USB is a pen drive. So low speed, full speed, high speed, it depends upon the USB how we may buy. So the high cost will be with a high speed, and the medium cost will be with a full speed, and the low cost will be with a low speed. So this is universal serial bus. So every external device is considered as a bus. So it allows the peripheral connections, and then it is just used to select this keyboards, mouse, scanners, printers, etc. So the evolution is so USB 1, USB 2, USB 3. So while coming years, we can also just see external storage devices with the help of flash. So it will just, these are the things which may be asked in some exams. So thank you for listening, guys.